Hello everyone, this is Bradley. So today I would like to replicate an animation which has been done by Ben. Ben is a super awesome artist and he's very young. I'm so jealous of him, but whatever. So he did this animation using geometry nodes 3.0 alpha. So which caught my interest is I honestly do not know how he has done with geometry nodes. This is not necessarily too hard. If you're talking about animation nodes, oh, I know what to do with that. But if you're talking about geometry nodes, I'm not so familiar with the curve areas. So I wasn't very sure, so I would like to challenge myself just to replicate this animation. So let's start. So within geometry nodes, let's just go to geometry nodes and add a whatever object because we're not going to use any part of that. So add a geometry nodes modifier. I'm going to lock this interface. Okay, so delete the original geometry. I think you can even delete these nodes, but I will just keep that for the moment. So here I'm just going to take the curved circle node. So I have a curved circle. For better visualization, I'm directly going to curve to mesh. Otherwise, you probably do not really see anything. And then just the radius. So we have a curve. So this is the starting point. Actually, the whole point of that kind of animation, I don't know how you interpret that because at some moment you may think, hey, it's just all this kind of a spline being formed while they're avoiding the intersection. But it's actually much simpler than thinking such a way. It's essentially just a kind of a circle being displaced differently. Oh, by the way, here's one thing I have to clarify. Although many things I say may be in confidence, but I haven't asked Ben about how he did the animation. So my method may be different from him, but I really think it should be the same. But I also think if you ask Ben about the details, how he did all this kind of animation, he will probably tell you everything. Anyway, so I'm going to distort all these kind of points on the circles. So I'm going to take a set position. And so I'm going to displace all these kind of points. And it's along with the normal direction. So I need a normal. So also to know there is an attribute which is called a curve tangent. So you feel like all these kind of curve attributes will have a curve, but I think the normal will also work. We will test. Just to know the normal is basically following the centrifugal force of that point. For example, for this point, the normal is that direction. For this point, the normal is that direction. Okay. But the tangent is always following the direction of a circle. For example, this direction, this direction. So I hope normal will work. So we take the position and take the vector mass to add them together. So whether you're working with a polygon or a curve, this is also the way how you displace a position along with a normal. You just add them up. The normal essentially is always a vector starting from the origin and it's going in this direction or that direction or whatever direction with a unit of 1. Basically, that's the idea. So it's basically drawing a circle. If you ignore this position, you can see there is a circle being drawn. Like this is always 1 unit far from the word origin. Okay. If you're working with a cube, it will also show something like kind of a circle. If you're only talking about normal. So this is the point. Anyway, we take the position and the plus normal. It's expanded outside with 1 unit. It means the normal is actually working, and then we just displace with different magnitude on these normals. Here we're going to take a noise texture. It's also possible that you use a random value, so we can actually try both of them and tell the difference between these two. So if we take the scale, and if we take the random value, all values from this point and that point will be completely random. There's no relationship to each other. And if you increase the resolution, you can see you just add more jaggedness to the entire whole system. However, if you use the noise texture, because this is a texture, so there's a map, there's a gradient from color to color. So even if you increase the resolution, you can see the general shape, it hasn't been changed very much. It may probably add a little more detail or resolution, but it does not change the general structure as what we have with the random value. In this case, to animate that better, I will probably use just the noise texture. But the noise texture has a disadvantage because it's a value from 0 to 1. And, and it's kind of too soft. We're going to add a little bit. So firstly, we're going to add a mid-level, because if you add 1 or add something beyond 0 all the time, then this circle will just be larger and larger. So for example, we take a multiply. Then you always increase the size. So here, what I want to do is to subtract 0.5. So that some points will draw inner, some points will just being drawn outer. This is kind of idea. Okay. And this is the tricky moment, and this is basically the major difficulty why I think how can Ben achieve that animation, because the circle he gets is kind of very smooth, but my circle is getting very jaggy. The answer, however, is pretty straightforward, that he's trying to take handles of this kind of Bezier curve. So if you set Bezier set handle type, and sometimes you can only choose either left and right, but if you shift click right, then you do everything. But now you have a warning sign which is telling that no Bezier spline in per the curve. I do not really know the type of circle, type of spline it has been drawn, but if it says not a Bezier spline, so that you cannot use handle, so you just change set spline type to make it into the Bezier so that you can use handle, and immediately you get kind of all this kind of soft result. And you can decrease the scales, increase the scale, or decrease the scale, and deal with the resolution. Increase the resolution, decrease the resolution, everything basically as you wish. And you can also change the mid-level. Maybe expand it a little bit more, or just to make it kind of average. So it seems like we finished the basic part, but this is really a start of a start of a start, which is basically the starting of all the suffering that we're going to have. But we really finished the major concepts of the whole thing. Next thing is really to make it more complex. So what we're going to do is I'm going to keep this circle to mesh. So this is a kind of point that's to separate the node tree before and that what we are going to do after. So in the Ben's animation, what we see is not really a curve, because we can see there's a lot of extrusion down there. So how to do that? I'm going to do this resolution. So this is actually showing kind of cubic shape of the bevel. If you change that to points in this case, then it will be kind of this is too much, so we're going to change the radius. So how to change the radius? Very good question. How to change the radius? I actually transform and scale. I think this is the easiest method instead of manipulating all this kind of value. So here I'm going to take a value, value, and yes, by changing these values, I have this. And note that this kind of line, this kind of cube is separating on this z-axis. So on this z-axis. So whatever up is above 0, whatever down, their z values is below 0. Okay. So by this difference, we can actually create a mask to draw these points down. So here, what we do is we get a setup position. I'm going to take these group nodes out by hit Ctrl P. Okay, so we set a position and create kind of mask. So we take a position and vector mask. You can also use the position from the most initial node, because this is the entire point of field workflow, that this node, this kind of nodes, this kind of attribute node, do not really contain any data. So their data is determined by the geometry you are finally attached to. So by this node by itself, it has no data. That's why linkage can mean different data in different contexts. But obviously you also see that this is too far away, so I'd rather just create another position node. But to know that the position nodes really does not contain data, so it does not really mean anything specific. Okay, anyway, so we separate X, Y, Z here. Once we set X, Y, Z, I'm going to float compare of the Z values. So if the Z is less than, then I'm going to hit the selection. Which means I'm going to move these points, which is whose Z-axis is less than 0. Okay, and then I'm going to just drop that down for maybe 10. Take the position, then we extrude all these kind of things just down 10. Okay, so this is how you actually make kind of extrusion whatever stuff. Actually, even without a shader, you can see there's a light area, there's a dark area, which is pretty interesting. Okay, so once we have this, we probably can manipulate these things a little bit better by changing all this kind of value. Another thing I would like to discuss is how to evolute this noise texture. If you would like to evolute a noise texture, always deal with its factor. I think we need to put the position. Because if you do not put the positions, the noise will just be eliminated if everything comes from the single point. So basically the whole point is noise is basically mapped from the texture. So this texture, maybe this large, it's actually infinitely large, but you map this point, this point, this point, then it will output maybe black and white from these point values. So you need a position node. So here we take the vector mass. And we combine X, Y, Z. Take the vector, and I don't want to evolute X and Y. You can. Actually, you can, but you realize its value is too large. So here we take a mass, and I'm going to divide for maybe 100. Whether it's X and Y, it probably does not really matter. So increase the values. You can see how it evolutes. And there is no intersection, not really. Or sometimes it has. So you try to deal with these kind of magnitudes, try to avoid that or other things. There are plenty of ways. Decrease the resolution is also a way. Kind of stuff. Just a kind of idea. You can also increase the dimension of the noise so that you can change the seeds. Also, to deal with the frequency is also a way. If you decrease the frequency, which is scale, then there's no sharp place. These are just a kind of idea. So finally, you have to determine what to actually do with this entire whole thing, because it's not really my business. Okay, I think I like this shape, so I would probably just leave with that. If you were like kind of automation, you can just type this frame. I also have a preset group node which is called time info. You can plug that in and you play the animation, decrease the division factor, then just wiggle. Okay, I think this is kind of cool and nice. Okay. So once we know everything about a single unit, we need to start with the instances. I'm firstly going to group everything which has been related. So hit Ctrl J, related to our set position, and isolate this circle curve, because next step is to instance. Here there is a versioning issue because we do not manipulate the scale of the object. So we can set position, but we cannot set scales or other things for the moment. I think they are their way, but I do not know when they will land in master. So for the moment, the kind of ways that a kind of workaround you create all these kind of instances is, let's just take a index float range. I have a preset which is float range. In reality, this float range is basically the index add and multiply. So this is basically how it does. I think this node will be updated. I will update them. Okay, so currently it only says start and step. Plug that into scale, and I'm going to always use mesh line, mesh line, mesh line. Mesh line method is basically create a vertices at the world origin. What you need to do is just to deal with these offsets and set the second position into 1. So this is a single vertices which starts at the world origin. So you can control H to hide everything. And this is the amount of points that you finally generated. And it's also on world origin. Once you have done that, you get the points. So you generate a different kind of circles, which is too much. And I'm going to change the step to be low. Okay, I think this is fine. Mesh circles instances, so instance the circle, which is okay. Just to know, really this is just a workaround because we do not have the node to set scale. But yeah, basically this is the idea. Cool. So now you realize the problem, like we have all this kind of circle, other things, but they are not deformed as we previously mentioned. It's because whatever we're outputting is instances. Instances are kind of a mirage, like an empty, but these empties are showing the objects from a collection or object or anything from the node tree. In this case, you always need to realize instances, and then you input this weird stuff. This is too much horrible simply because the amplitude is too much, resolutions kind of not enough. You can deal with a lot of them. For example, this scale, deal with the scale, other things. Now we have this kind of stuff, and you can try to manage the frequencies or whatever stuff as you essentially wish. You also realize it is just to simply correct our previous issue that different curve is having different radius at the same time. So basically, whether you're close to center or away from centers, this kind of thickness of the whole curves are always basically the same. Next step is to do the transition of this animation. So in Ben's animation, it's not always this kind of wavy structure, but rather it's originally kind of circle. Then it goes to kind of wavy structure. And when you have such kind of a shape key like kind of the effect, you almost always, I think, you need to think about the mixing effect. Either you mix RGB or you mix vector. Here we use mixed RGB because there's really not much difference from the vector and the color. Both are just the XYZ or RGB. So these are kind of 3 floats corresponding to each other, so they can convert freely without any kind of problem. In this case, we just take the position into the color 1, vector into color 2, and you can see original states and our destination states. And within factors, you just put whatever kind of fall for masking, then you will be able to do the kind of transition effect more interestingly. So I've made different kinds of fall. I have delay fall, radial fall, proximity, whatever. But I think just to take an example, the position fall is probably the best one to discuss or to show. Like you just select an empty object, and you can immediately see the effect that right side is being transformed, the left side is completely clean. and you can move with your empties, then you can see the effect better, and you can even rotate that. So this is the concept of Falloff or masking or whatever you call it. Or even simpler, maybe you just put whatever random value, you can even still achieve the effect as well. Just not very interesting. Okay. However, to replicate Ben's animation, we're going to use the Radial Falloff. So basically, I have all this kind of Falloff you can choose, but I'm going to use the Radial Falloff specifically to replicate Ben's animation. Okay. And we need to put the position into vector. Radial Falloff is kind of very unique Falloff, and that's why immediately you may realize it's not as obvious as the directional Falloff that we saw earlier. And you might start to worry about this red line. Actually, this red line should be a bug. I think people already reported that somehow. So you do not need to worry about that, because I will show you it's already having its effects perfectly. So although the effect is not very obvious, but if you select node hit M, you disable the mode, then you realize there's actually difference between with or without this node. So the idea of the Radial Falloff in this particular case, when we select the 0, which means XY plane, then it's started from here, the 0, and then runs a circle and until reach the Falloff to be 1. So which means basically every part has a Falloff, even though the value is more like 0.1, I guess, and 0.5 here, like 0.25. Which also means if you just color ramp, you can actually isolate the area that has effects, not having effects. And one more important thing is by having this offset, you can actually rotate this entire whole thing. So this is how it's working. However, here we run into an issue that because the entire Radial Falloff is based on a coordinate, so we do not really distinguish from spline to spline. That's why we are only affected the same areas all at the same time. But if I would like to create any kind of variances, then it becomes kind of difficult to think about, right? How am I supposed to do this? Turns to be the problem. So here we actually have discussed similar kind of points when I was talking about this kind of waving animation earlier. And we're going to use the same cheating method as well. So within this offset, we're going to take a random value. And if a random value put into the offset, we do not really immediately see any kind of effect. And rather, if you increase this maximum, it creates kind of chaos, and we do not necessarily understand why. The reason for this entire whole thing to happen is not because of this red line. This red line is again also a bug. I don't know when they will fix that and what's the exact reason, but anyway. The reason is that we need to understand the mechanism for this random value to be generated. This random value actually has two kind of seed. One is a seed, another is ID. So if I have 100 points on the whole system, like in total, then it will generate 100 values because the ID is different. Even if I have the same seed, but based on ID, I will generate a different group of random values. So 100 points, 100 ID, 100 random values. But we all have one seed instead. Okay, so this is the idea. If I change the seed, then I change the whole system's, all the 100 value will have another different 100 different values. Everything has been refreshed. So this means if I can, instead of 100 IDs, if I can create 4 IDs, then it will be shared across these 4 splines, and each spline will be affected in a group as a whole. Okay, so this is the idea. It might sound to be confusing because, but I will show you very soon. So the way to distinguish these 4 splines using vector, the easiest way is to use the vector length or vector distance from this point to the world origin, because it's running a circle. So this is very easy to distinguish using such a way. What we're going to do is basically just actually simply just a vector mass, not a vector rotate, but a vector mass. Vector mass. Yes. And then you can use either length or distance. They're essentially the same. The difference between length and the distance is length is measuring the vector distance to the world origin, but the distance you can choose maybe a different location you want to measure to this idea. So just take a length values into the ID. Then immediately you can see the effect. Like different splines is being affected at different angles. We can change the seed so that more obvious. Like for our outermost splines, we have these areas being affected. Sorry about my drawing. And for our first spline, this area is being joined. So they are facing different direction, but they have all this kind of weird, interesting transformation. And I'm going to crush this Falloff so that we can easily see the effect. Here we run into another two issues. One issue is that actually you can always realize there's more kind of ridges compared to the outer part of spline. The reason it happens is because we're instancing the same splines, so the interval from the vertices to vertices increase as size gets larger. So we need to take a resample curve, and I think it's best to use the length so that you can choose the interval from vertices to vertices. I think I'm going to take 0.2, probably 0.1, which is high resolution. Be careful with this interval amount, because if it's too low, it probably generates too many vertices that finally crash your computer. But it should be fine for now. And increase the count, everything procedural. And the second issue is how to actually animate these things. Okay, to animate that is basically just to change all this kind of value from 0 to 1 or other things. So very easy, just to type, you just plus minus whatever. So here, if I we subtract the Falloff, then there's nothing. Everything is below 0. But then if I slowly increase the value, and you can start to see there's radial Falloff effects. There's everything is rotating. This is pretty cool. I think it's also possible that for you to deal with this kind of counterclockwise or clockwise rotation, but I do not want to investigate this. But if you would like to investigate, I would ask you to think about the minimum and the maximum, because if you reverse this relationship, then originally it was counterclockwise, but now this is clockwise. So you can change a random value, random boolean. Actually, random boolean will be fine. So let's actually do that. Take the random value and switch type into boolean. Use the same methods. And we're going to invert the mask for the other one. Booleans, when it's output, it's 0 and 1. So the offset is basically map range. Reverse it to be 1, 0. So that we have clockwise, counterclockwise. Yeah, this is counterclockwise, and that is clockwise. Pretty interesting, although I think it's kind of too chaotic to say it kind of interesting, but yeah, this kind of idea. This node tree is probably pretty large at some point, and we really discussed different concepts like how to deform, how to instance, and how to manipulate all this, how to make a Falloff. But if you follow this tutorial carefully, I think you should resolve each section without any problems. If you have any questions, you can join the Discord or comment below. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.